Okay, so in this video, we're going to be talking a little bit about elasticity of demand. And this is a business application, so it typically doesn't occur in traditional Calc 1 or Calc 2 books, but it will occur in business calc books. And so we want to make sure we cover both the business applications and the physics applications. So we're looking at elasticity of demand, and the equation is typically given in some form that looks like this. So we have the price divided by the quantity written in terms of the price times the derivative of the quantity. Now, the quantity is often thought of as the demand. That's why it's called elasticity of demand. So how much is a quantity is desired given a particular price. And so sometimes you'll also see the equation written this way, where it's price times the derivative of the price divided by the demand, the derivative of the demand relative to the price divided by the demand itself. I've also seen versions of this in different books with an explicit minus sign out front in order to make the elasticity equation positive so that you don't have to deal with these absolute values. Because the derivative of the demand relative to the price should go down. That's what the law of supply and demand basically says. As the price goes up, the demand goes down. And so therefore, putting a minus sign in here will account for the absolute value, because otherwise you would expect this value to be negative. Now, in terms of interpreting our elasticity of demand, what the rule is basically is that if E is equal to 1, or the absolute value is equal to 1, this is called unit elastic, and that is essentially your optimal price. But if you are for the highest revenue, but if you were greater than that, then you would say that your demand is elastic. So you would want to decrease price to get higher revenue. And if your elasticity value is less than 1, then you would say it's inelastic. And so you would want to increase the price for higher revenue. Now, let's look at a specific example and actually go through this and then interpret it according to our rule here. So here we're given a price. The price is equal to 200 minus 0.03 Q. And we want to know what the elasticity of demand is when the price is equal to $50. Now, in this kind of a problem, you're given the price in terms of Q and not the Q in terms of price. So we're going to have to do a little bit of algebra. In some problems, you will be given the demand equation Q in terms of P explicitly, and so then you don't have to do this. But occasionally you do get it in this form. And so in this case, we're going to have to do a little bit of algebra. So I'm going to move the 200 over to the other side. So P minus 200 is equal to negative 0.03 Q. And then I'm going to divide everything by negative 0.03. So P minus 200 divided by negative 0.03 equals Q. And if we do a little bit of algebra, we're going to get, let's see, 200 divided by 0.03 is going to be 20,000 over 3. And then minus, and then 0.03 flipped over is going to be 100 over 3 P equals Q. And I just converted my decimals to fractions. Since 3 doesn't divide evenly into either 20,000 or 100, I'm just going to leave them like that until I have to evaluate them at the end. It's probably safe enough in this problem if you carry a couple of decimal places to convert them to decimals. But I'm going to leave them like this for the moment. And then this is my demand equation now. My demand in terms of the price. And so I'm going to take the derivative of that. So d prime of P. the derivative of Q with respect to P is going to just be negative 100 over 3 in this case. And then I'm going to put that into my equation, and I'm going to plug in P is equal to 50. So my elasticity is going to be 50 times my derivative divided by my demand with 50 plugged in. So 20,000 over 3 minus 100 over 3 times 50. And so let's see what that simplifies to. I could multiply both the top and the bottom by 3, and that would get me 50 times negative 100 divided by 20,000 minus 100 times 50. Again, just canceling all the 3's in the denominators. And so then we would end up with 100 times 50 is negative 5,000 divided by 20,000 minus 5,000. So that's going to be negative 5,000 divided by 15,000, which is going to be negative 1/3. Therefore, the absolute value of E is equal to 1/3, and this is less than 1. And so if we go back to our rule, if it's less than 1, this is inelastic. Therefore, to increase revenue, raise the price. So now one thing is worth noting here is that this elasticity of demand is about revenue. It's not about profit. And so the maximum revenue point and the maximum profit point may not be the same thing. So a further analysis may be necessary in order to determine if, in fact, you have optimized profit at the current price, or if simply you're trying to increase revenue.